everybody, it's Miss Marie. And today for STEAM Thursday, I thought we would do some experiments with water. It's summertime, it's hot out, it's a perfect time to do a little bit of summer water experiments. And my favorite ones involve floating and sinking. So I'm gonna read you this book. It's a really nice book from the Everyday Science series, and talks about why things float and why they sink. And then we're going to do a little experiment outside, which you will need some tin foil and pennies, as many pennies as you can gather together, because the more pennies you have, the better. And we're going to need a pool for water, or you could use your sink. You could use the tub, you could use a big pot of water. I have a little kiddie pool that Hero uses to cool off in this hot weather, so we're gonna be going outside using that. But first, let me read you this book, Floating and Sinking. And this book is written by Peter Riley, and it's published by Gareth Stevens Publishing, and has great photographs that are really clear and easy to see as well. And a table of contents, which is a page that tells you a subject and what page to turn to if you want to read about that subject. For example, if I wanted to read about water pushes up, I would go to page 12. Let's see, I'll go to page 12 real quick and just show you. And that's the title of that chapter, Water Pushes Up. So this is a great nonfiction book. It has a table of contents, which tells you where everything is. And it also has, in the back, an index with some useful words and some answers to questions in the back. So it's a really good example of a nice, clear nonfiction book. So let's go to the first page. Float or sink. Some things float, some things sink. Leaves float on a stream. Ships float in the sea. My son is on a ship somewhat like that right now. Or they sink. Pebbles sink in the pond. Soap sinks in a bowl of water. I bet you didn't know that. If you put a bar of soap in there, most of the time it will sink, except for Ivory soap. I think Ivory soap always floats. Sorting materials. Lucy has some objects that are each made of a different material. She's got a plastic fork, a marble, a coin, a wood block, a cork, a sponge, and a metal spoon. She wants to see which materials will float and which will sink if she puts them in water. Lucy made a chart of her predictions. A prediction is something you do before you do the experiment, right? So she's predicting that the sponge and the cork and the coin will float, and that the spoon, marble, block of wood, and plastic fork will sink. So write down your predictions too. What do you think will happen? Turn the page and find out. Do you think she's right? I feel like she might be wrong on this one and this one. Let's see. The plastic fork, the cork, and the wood block float. The marble, the coin, and the metal spoon sink. And you can see that very clearly in that photograph. The sponge filled with water, but floated just below the surface. Were Lucy's predictions right? Were your predictions right? Some of hers were right and some of them were wrong. Carl has a brick and a piece of wood that are about the same size. He wants to see if they will float. The wood is light in weight. It floats in the water. The brick is heavy and it sinks in the water. So even though they're about the same size, one sinks and one floats. That was a pretty interesting experiment that he did. Water pushes up. Water pushes up on objects. The push of water is strong enough to make lightweight materials such as wood float. Even large logs float. Do you see all those logs floating in the water? Feel the push of water yourself. Screw the lid on tightly to an empty plastic bottle. Push the bottle underwater and then take your hand away. What happens? Turn the page to find out. Let's predict first. What do we think is going to happen? He's pushed an empty bottle. It has his air in there. He's pushed it under the water. What's going to happen when he lets go? Will it stay down there? Watch the water. The bottle rises through the water and floats to the surface. It even pushes the water up so fast that it makes sort of a wave there. The strong push of the water makes the bottle move quickly. Pour some water into a clear bowl. Put a mark on the bowl at the top of the water level. Slowly push an empty bottle with a lid on it into the water. The water level goes up. What do you think will happen when you take the bottle out of the water? Well, if it went up when we pushed it in, I think when we take it out, the water level will go down. What do you think? Oh, let's see. I don't think it tells us. Some objects are hollow. They have air inside them. An empty bottle is hollow. It is full of air. Hollow objects float because the air inside them makes them lightweight. So I think when she let go of the bottle and took the bottle out, the water went back to the regular level. Some objects are solid. They have no air inside them. Solid objects made of heavy materials sink. Solid objects made of lightweight materials float. There's a rock, it sunk, and there's a piece of wood, it's floating on top. Adam fills an empty bottle with sand. He puts the bottle into the water. Adam's bottle sinks. It is not hollow anymore, it is full of heavy sand. And sand is quite heavy. Natasha puts a marble into an empty bottle. She puts the bottle into the water. Will the bottle float or sink? Let's see. Is that marble enough to sink that bottle? Let's turn the page and find out. No. Natasha's bottle floats. The bottle is still hollow. It has still lots of air in it. A boat is hollow. It has air between its sides. See, this is a curved out boat, and it's got air in the middle. When you put a small load into the boat, you push some of the air out. So the boat might sit a little lower in the water. You see that? The weight of the load makes the boat sink a little. If you put a very large load into the boat, you push out most of the air, and then what happens? The weight of this load is too heavy for the water to push up, and so the boat sinks. You see it's loaded up with marbles at the bottom of that tank. Pretty cool. I love this stuff, it's fun. Make it float. Make a ball out of clay. Put the ball into the water. The ball is solid, not hollow, so it sinks. Make a dish out of the polymer clay. Put the dish into the water. The dish is hollow, so it floats. How small can you make the sides of the dish and still keep it floating? I don't know, if you have some polymer clay, that means not Play-Doh, some other kind of clay. You can try this out. Boat loads. Adam has 3 boats. They're not really boats, they're bowls. Each boat is about the same size, but each one is made of a different material. We've got a metal bowl, a plastic bowl, and a styrofoam bowl. Adam tests the boats to find out if they all float. They do. Then he sees which boat can hold the biggest load. He adds marbles to each boat until the boat sinks. Which boat do you think will hold the fewest marbles? Turn the page and find out. Do you think they'll all hold the same, or do you think one boat will sink faster than the others? The metal boat is the first to sink. Adam made a chart with his results. See, he's made this chart with check marks. It says metal bowl sank first, plastic bowl sank second, and styrofoam bowl sank third. Try Adam's test and make a chart of your results. Are your results the same as Adam's? So if you have these things, you could do that. We're gonna do our own testing later. Make boats of different shapes using the same amount of polymer clay for each one. It's important that you use the same amount. We're going to talk about this later in our experiment because you want to make sure the boats all use the same amount of material so that it's the design of the boat that decides how fast it will sink or float. Which shape holds the most marbles before the boat sinks? What do you think? I don't know. Would it be one that's flatter or one that's got higher sides? Not sure. Oh, they didn't tell us. We would have to find out. Well, we're going to find out using our own materials. We're going to be using a piece of tin foil, or aluminum foil it's called sometimes, and we're going to be measuring it to make sure we use the same size every time. And we're going to take it outside and we are going to fill it with pennies and see what shape holds it the best. I'm not going to tell you what shape. You're going to have to try that yourself. I'm only going to build one, but you can try many different things, including folding the foil in half to make the sides thicker. You can try making the sides really deep, like a canoe. You can try making it really flat, like a container ship, and see if you load it properly, which one will hold the most pennies. It's really fun. So come outside with me and I'll show you how it's done really quick. Bye. Okay, so I'm outside now. I brought out my tin foil, and I'm going to make sure I measure it so that if I want to repeat the experiment, I do it with the same size tin foil. So mine is 12 by 10, and that way I could keep cutting the same size foil, or have my grown-up cut the foil for me, so that when I repeat the experiment, I'm always using the same size, okay? I've got a pocket full of pennies, and a pool full of water, a kiddie pool. And we're going to try to make some boats and sink them with pennies. All right? Okay, so this is here with kiddie pool. So if you see him come running over, it's because he wants to play. So bear with me. I'm going to fold my foil into a boat shape. I'm not going to tell you what the best boat shape is. That's for you to discover. You could also try folding it in half to see if that makes it stronger or better. I'm going to just try like a regular, like a canoe or kayak shape. Put that in the water. Let's make sure it floats pretty well before we start putting the pennies in. All right, can you see that? Great. And I've got a pocket full of pennies. I bet your family has a ton of pennies they'll let you play with. It's important that you use all the same size coin, because so either use the pennies, nickels, whatever you have a bunch of, because you want to always use the same weight when you try to sink your boat. So I'm going to just start placing these in there. I'm going to spread them out so there's not too much weight in one spot. Can you still see it? Perfect. Come back, little boat. It's starting to fill up with pennies. And I forgot to count mine, but I know I have a lot of pennies in there. So I'm going to keep on piling the pennies in until it sinks. And usually do one at a time, so as not to overload it, but I'm going to dump them in there and say, oh, did it sink yet? It didn't sink yet. So I have to go get more pennies. And I'm going to keep loading it up with pennies until it sinks, and then I'm going to count them up, and I'm going to do the experiment again with a different shaped boat. And that is the penny in the boat experiment. I hope you have fun. I hope you learn a little bit about why boats float and what shape is best for a boat to be to load it up with some cargo. This one's doing pretty well right now, but it is taking on water. I don't know if you can see that. It's starting to take on some water. So I would say it's not the best design because it doesn't have that many pennies in it yet, and it's already starting to sink. All right, try it out. Let me know. Oh dear, there it goes. I think because I shifted the weight to the front. So it's a really fun experiment, and let me know what shape works best for you. All right, have a great day.